Okay, so we've been talking about equivalent ratios and equivalent ratios in tables. So we've looked at tables where we may be going across, but sometimes in tables we can go down. And when we are going down in our tables, we want to make sure that we are finding the pattern and that the pattern is consistent in the direction that we are going. So for instance, if I were to go for 2 and looking at 9, for every 2 adults, there are 9 students. That's my ratio comparison statement. So I did a ratio of 2 to 9, 2 adults to 9 students. But there's parts of my chart that are missing. And we need to look at this chart to determine the missing spots. So we've been using our little rainbows or french fries or noodles or whatever you want to call them. And we've been using them to find our pattern. So if I were to drag my noodle and I were to place it on the 9 and move it so it was up, let's move it this way. If I were to move it to the 59, I would have to figure out what that pattern is. Or I could figure out the pattern, or I could see if there's a pattern from 2 to 9. Now, when we're looking for a pattern, we are either multiplying or dividing. We aren't adding, we aren't subtracting. It's either multiply or divide. So if I was looking from 2 to 9, if I multiply 2 by anything, I'm not getting 9. And if I divide 9 by something, I'm not a whole number, I'm not getting 2. So our pattern is going to go down the side. So I can ask myself, 9 times what is going to give me 54? Well, 9 times 6 is going to get me 54. So I'm timesing this by 6. Now you need to know that whatever you do to one side, you have to do to the other side. It's the same rule. Whatever you do to one part of the ratio, you have to do it to the other part of the ratio. So I would have to sit here and do times 6. So 2 times 6 is 12. Okay? So now I'm looking. I have an empty spot. So if I have an empty spot, if I have that empty spot, and I'm dragging this to 81, well, I found the number. I got to figure out, well, 2 times, well, I don't know what number I'm looking for, so I'm going to go to the 9. 9 times what will give me 81? Oh, I know that 9 times 9 gives me 81. So I have to do 2 times 9. And 2 times 9 is 18. Then I'm going to sit here and I'm going to go, okay, well, I'm going to drag my noodle to the 22. Drag my noodle to the 22 box. Well, I'm looking here, it's blank here, so I don't know what I'm timesing 9 by. But I gotta sit here and think, okay, 2 times what is gonna get me close to 30? Or, I'm sorry, 2 times what is going to give me 30? Well, 2 times 15 is gonna give me 30. Oh my goodness. 2 times to get me 22. See, sometimes you gotta make sure you're paying attention to where the noodle's located at. 2 times what gives you 22? 2 times 11 gives you 22. So again, what you do to one side, you have to do to the other. So you got to do 9 times 11. 9 times 11, 99. Bring your noodle down. Bring your noodle down. Now we got to figure 2 times what gives me 30. And I had already said that previously when I had made a mistake. And 2 times 15. So if I do 15, 2 times 15, so I got to do 9 times 15. So 9 times 15 is 135. Okay, so now we got to drag our noodle down. Drag our noodle down. And now I got to ask myself, 2 times what? Oh, that's an empty box, so I don't know what I'm multiplying by 2 to get. Now I got to do 9 times what gives me 162. So I'm looking at 9 times 18. So now I got to do 2 times 18. Because again, whatever you do to one side, you have to do to the other side. And 2 times 18 equals 36. Okay, so again, our equivalent ratio table is all about the pattern, whether the pattern's going straight across or the pattern's going up and down. You just have to determine where that pattern lies. Okay, and that's how you work with and filling in equivalent ratio tables.